Well, hello guys, Mr. G here with another video for the grade 12. This is going to be the third video of the control test in 2023 done at the Northern Cape. And this time we're going to the chemistry part. The question 5 say the letter A to H in the table below represent 8 organic compounds. And then you have 8 organic compounds in this table. Okay? The question 5.1 say write down the letters that represent an alkene. And as usual, as I said before, let's try to identify what type of compound are these ones here. So let's write the homologous series of most of them. For instance, A, you can see here the functional group, which is OH, and this one is the 4-alcohol. Compound B, you can see the functional group on this side here, and that is going to be an aldehyde. That one is an aldehyde. Compound C, will go back to that one. Compound D ends in ane, but it have bromo in part of the compound, and therefore it's going to be a halo alkane. It's a haloalkane or alkyl halide. Compound E is a oic acid and is a carboxylic acid. Compound F will come back to that one, compound G will come back, and compound H is a on and is therefore going to finish, there you go, and is a ketone. Is a ketone. I recommend to do this one. However, these compounds here now will have to look at C, will have to look at F, and will have to look at G. Now, if we go back to C, for instance, you only see carbons and hydrogen, so it's a hydrocarbon, one of them. So this one I'm going to write here for C, I'm going to write here hydrocarbon. The same happened to F, and the same happened to G. All of them are hydrocarbons. Now, obvious, one of the three hydrocarbons, either alkane, alkenes, or alkynes. Now, in compound F, you can see here the 3 carbons here, all these, and that will mean that there must be a triple bond there. So compound F must be an alkyne. Compound F is an alkyne. Now we have C and G. Compound G, as you can see here, everywhere you can see single bond. It's quite easy to see, guys. They are not see a deep double bond or anything. So this one must be an alkane. And here you can see on this side there, you can see that there is missing bonding. We'll have a carbon which have only one hydrogen bond, so this one must be an alkene. However, if you think you're going to get confused, there are 2 options to make sure they are in one of those. One of them is use the general formula of each of them. You can get the general formula of alkenes, alkanes, and alkynes and try to see which one is more suitable. And the other option is a little bit longer, but you can draw the structure, the structural formula for each of them. So question 5.1.1, which one is an alkene? Now for this one, we're going to use the general formula now. We already identified, but let's make sure. The general formula is CnH2n. So if we count here, we have 2 carbons at the beginning, because you can see the 2 right there. We have here 2 carbons, 3, 4, 5, 6, 7, and 8 carbons. So we have C8. H, let's see how many we have here. So let's count the hydrogens. We have 3 times 2 is 6. 6. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we have 16 hydrogens there. 16 hydrogen, and if you can see here, this one followed the same trend here. So C is 8, H is 2 times 8, which is 16, guys. This one is an alkene. So for sure it is an alkene. The compound is compound C. Now question 5.1.2, a saturated hydrocarbon. The saturated hydrocarbon is going to be an alkane. Alkane is the saturated hydrocarbon. And once more, we said here is going to be G, but we are going to make sure. The general formula for alkanes is CnH2n plus 2. So we are going to make sure it follows the trends, okay? So we're going to have how many carbons? Let's count quickly. 2 carbon. Here you can see the carbon with a 2 in the bracket, so it's 2 carbon, 3, 4, 5, 6, 7, and 8. It's also 8 carbon in this case. How many hydrogen? So let's carefully count. 3 times 2 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 hydrogen. So you have now hydrogen, 18 hydrogen. So let's see, follow the trends. If it's 8 carbon, will be 8 times 2 is 16 plus 2 is 18. So this one is an alkane. The answer is G. So I hope this one is clear. The best way is to find the general formula, guys, to make sure. Now we're going to the next question. Write down the IUPAC name of compound B. Now compound B is this one here on this side there. And here's compound B, guys. So now the first step to name compound is to identify the homology series. This one you can see is an aldehyde we already identified, and therefore it's going to end in al. The second step is to look for the longest continuous carbon chain that has the functional group, and here we have two options, one going straight and the one is going and turned down. If you go straight, you have 1, 2, 3, and 4 carbons, but if you go down, you have 5 carbons. So the going down is going to be the one we are going to be using. Okay, so 5 carbon is pent, so it's going to be a pent, but remember I told you before that from alcohol onwards you're going to add the AN, so it's going to be pentan. Now what are you going to do then? You're going to count the carbons starting from the N nearest to the functional group, so carbon 1, 2, 3, 4, and 5. In an aldehyde is always the first carbon is in the functional group, so it is 5 carbons there. Now then you're going to look for any substituent, and you can see here we have a methyl in the third carbon, so this is a 3-methyl. 3-methyl, I'm going to write it down here, and then it's just to write the name. So the name of this one is 3-methyl with a dash there between numbers and letters, pentanal, and that one is the name of the compound here. Let's move it down to this side. This is the whole name of the compound, 3-methyl pentanal. I hope it's understood now. Now let's go to do 5.2.2. 5.2.2, write the IUPAC name of compound F, and that one there is compound F. So let's go down here and write compound F here quickly. Now, to write the name of this one, I recommend you to draw first the structural formula, and let's do so. We have a carbon with 3 hydrogens, then we have a carbon, we have another carbon, and we have a carbon with 1 hydrogen on one side and a C2 carbons with 5 hydrogen as is represented here. Note, I did not join the carbon there on that side yet. So we have a carbon with 2 hydrogens, and then we have a carbon with 3 hydrogens. So now we're going back and we're going to join this side here. Note that each carbon must have 4 bonds. So these carbons already have 1 and 1. So 2, 3, and 4 bond is an alkyne, as we said before. Okay, so it's an alkyne, and therefore here you can see the functional group, and therefore it's going to end in -ine. It's going to end in -ine. Alright, now first we're going to determine the longest continuous carbon chain. And here once more we have two options, straight and going down and turn there. So if you go straight, you have 1, 2, 3, 4, 5, 6 carbons. If you turn, you have 1, 2, 3, 4, 5, 6 carbons. So either one have 6, therefore we're going to take the straight one. And if 6 is hex, you do not have to write the AN because that one is only as from alcohols onward. So it's hex. Then we're going to count the carbons starting from the N nearest to the functional group as it is shown here. So that is how to count the carbon, and you can see that the triple bond is in the third carbon, and therefore it's going to be 3-ine. Now we are going to be looking for any substituent, and as you can see guys, here you have an ethyl. This one is an ethyl in carbon 4, it's a 4-ethyl. And now to finish, all we're going to do is to combine all this. So the name is 4-ethyl hex, all this together in words, hex 3-ine. And that is the name, 4-ethyl hex 3-ine. This is the answer for this question. Let's go to the next question here, which is question 5.3. Okay, now question 5.3 say write down the structural formula of compound D and compound H. So we are going to compound D and compound H. Okay, so we're going to go to a new page to answer that question. Okay, so here is compound D. Now compound D, the first of all, when you write in the structural formula, we're going to start from the number of carbon. In this case is bute. So bute is 4, and we're going to say 1, 2, 3, and 4 straightforward like that. And in this case, I'm always going to call the first carbon here 1, 2, 3, and 4. I'm not going to connect any carbon yet. Now in carbon 1 and carbon 2 you have bromos, like you can see here. So in this side you will have a Br, and on this side you will have a Br. And in carbon 3, as you can see on this side, in carbon 3 you have a methyl. And I'm going to do the methyl at the bottom here because of space. It doesn't really matter where you are doing it. And this is all. The rest of the question is now to combine all the carbons and add the hydrogens there. So now it's combining the carbons and adding the hydrogen. Make sure each carbon has 4 bonds, guys. And this is the structural formula of compound D. The next one is compound H. And here is compound H. The first thing you have to do, as I said, is identify the number of carbon. Pent is pent. In this case, it is going to be 5. So it's 1, 2, 3. I'm not going to connect any carbon yet. 3, 4, and 5. And I'm going to call this one carbon 1, 2, 3, 4, and 5 in that order. Then I will remove the numbers. Okay, so now what you need to know, this one is a ketone. You can see here it ends in on, and the functional group is in the second carbon. So here I'm going to have AO, and this one is going to be bonded there. Okay, so then now I can join the other carbons if I want. Now 4-methyl. In carbon 4 I have a methyl, as you can see there. So in carbon 4 you will have a carbon with 3 hydrogens, as you can see here. And the question is almost done. Just now I have to add the hydrogens, which I'm going to do real fast here. Make sure
that every carbon have 4 bonds. And guys, this one is question 5.3.2. Now question 5.4. Compound A and compound E are heated. So compound A and compound E. We're talking about the alcohol and we're talking about the carboxylic acid. This one is ethanol. You can see they have 2 carbon, and this one is propanoic acid. The question said, write down the type of reaction that take place, and that one is esterification. Esterification, okay? And now the structural formula of the organic compound. Now, to write the structural formula of the organic compound, remember that it's going to be the combination of the alcohol and the carboxylic acid. And you need to know that then an ester is formed. In the name of the ester, first always would be the alcohol, and second the carboxylic acid. Okay, so in the name is always going to be like that, and in the compound it's going to be that way as well. So let's go to the next page so we can answer this question. In this question you have that ethanol is going to react with propanoic acid. So the name of the ester that is going to form is ethyl. This one is coming from the alcohol, propanoate. Propanoate. This is the ester that is being formed. It is not a question. It is not a question, but it's important to know. Now, ethyl. So the ethyl part will have 2 carbon with the O. This is the part that is coming from the alcohol, and the part that is coming from the carboxylic acid is the carbon double bond O. 1 carbon, 2 and 3 carbon, and this one is ethyl propanoate, which is the ester being formed. And guys, saying that, this is the end of this video for question 5. Okay, next time we'll be doing the video for the next equation, which is going to be physical properties. You can see it here, but for now I think long enough. So thank you for watching. If you think it helped, please thumb up and subscribe for the channel. I'll see you next time. Mr. G here.